today we will discuss about the relationship between Kc and Kp. So basically, in order to find the relation between Kc and Kp, it is mandatory that there must be at least one reactant that should be in gaseous state, right? For in order to find the Kc. For example, we have reaction 2A plus 3B plus C is equal to, and the reaction is it's D plus E. Right, this is the reaction, and let's find Kc for this reaction. So Kc will be equal to, basically, okay, this is in gaseous state, this is in liquid state, this is in solid, and again this is gaseous, and this is gaseous as well. So for this, D, E, and here we have A. We will only write here A because in order to find the relation between Kc and Kp, we require only gaseous molecules. So this is the concentration of Kc is equal to dE upon A square, right? Okay, if we want to find the Kp, let's find Kp for this. So the Kp will be equal to D E and A square, right? This will be basically Kp. Now let us find, we know that we always put this Kc in terms of mole per liter, right? We put this in terms of mole per liter, or you can say yes, mole per liter. Let's name this mole per liter as C. So we can write this as Kc is equal to concentration of D, concentration of E upon concentration of A, like this, right? And we know that PV, according to ideal gas equation, PV is equal to nRT, and here we can say PV is equal to N upon VRT. So we know that this N upon V is basically equal to C, so it can be like this as well. P is equal to CRT, so we can put this equation in this as well. So it can be Kc is equal to CDRT. Here it can be CERT. It can be CART whole square. It can be like this as well, right? Now we know that okay, now basically this is equal to Kp. This is equal to Kp basically, and here Kp is equal to basically it is equal to Kp is equal to Pd upon Pe upon Pa whole square, right? And in this P pressure we have included this P, right? Now basically let's multiply them. We know that Kp is equal to now Cd upon Ce upon Ca, and it will be RT 1 plus 1, 1 plus 1 minus, and here we have 2, right, minus 2. It will be like this. And now as you can see over here, this value, this whole value is equal to, basically this is basically K, right? This whole value is equal to this, right? So we can easily replace Kc instead of that. So here we will put Kp is equal to Kc dot RT delta Ng. This will be the formula which will be produced. Now here you will be wondering that how delta Ng came over here. As you can see over, delta Ng is basically equal to, number of moles of product minus number of mole of reactant. As you can see over here, this 1 plus 1 are of product and this 2 is of reactant. So this is how this formula is generated, right? And this is how it is generated, right? So now if we want, like, we have the formula now, which is Kp is equal to Kc dot RT delta Ng. This is the formula which is right now, and this Kp is basically taken in the terms of ATM, Kc in the terms of mole per dm cube, and this R is taken, that the value of R is taken as 0.082, which is dm cube liter, it is mole dm cube upon mole dm cube upon mole Kelvin, right? And this T is also taken in the terms of Kelvin, and here it is Ng is equal to number of products, or moles of products minus moles of reactant, and they must be in gaseous state. Remember this thing, right? This whole is very important, right? So if you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys. So in my next video, we'll be looking into the word problems of this equation.